Right, so before we start looking at how the probes themselves are doing the monitoring, let's just have a look at some of the monitoring practices. There are two ways to monitor OTT. There's so-called passive testing and so-called active testing. Now, Bridge Technologies mainly use the active testing model, and we'll explain that later. But before that, I'll just run you through passive testing so that you've got an idea of what it involves and some of the reasons that we don't actually do a lot of passive testing. Analysing all of the OTT traffic coming from a single server requires that every IP packet be inspected, because unless you inspect the IP packet header, you don't know its destination and what kind of traffic it is. So that immediately places a load on the probe itself, because every IP packet in the interface needs to be inspected, irrespective of whether it's a control message, whether it's traffic for some other destination, whether it's the service I'm looking for, or whatever. So if there are a small number of streams and a small number of, say, VOD servers or an origin server, then that in itself is not too much of a problem, because the hardware is more than capable of analysing this sort of volume of data. But as the data starts to increase, as you increase the number of streams, then the work that the server needs to do, the probe needs to do, increases, and it increases sort of exponentially in a way. So the first problem we have with passive testing is it doesn't really scale that well. And in the strictest sense, passive testing doesn't test the user data itself. So it's looking for traffic, but it's not actually doing, unless you do something else, it's not actually looking at the video and audio. And of course, OTT is a point-to-point system using TCP/IP. We discussed in the previous session, session 7A, when we looked at the theory, every single OTT stream that goes to a customer is a point-to-point. So you can immediately see the problems with scaling this. The more customers I have, the more traffic I generate. We do have the ability to do some passive monitoring in a Bridgetech probe, and I will explain that and show you it live on a probe itself. So we can filter the traffic on an interface, and this gives us the ability to filter out traffic coming from a particular server, or filter in a traffic going to a particular range of destination addresses. So this gives us an ability to filter some of the traffic. But the problem with the passive testing in a Bridgetech probe is that it doesn't currently generate any alarms. So although we can graph the traffic and we can see some data and figures, we can't actually cause any alarms to be fired. Here you can see some of the graphs. We'll look at these in a bit more detail when we actually look at the live probe. So if we do passive testing, we are limited due to the scalability of the model. If we do active testing, we can be immune to these sort of scaling issues. But, of course, there's always going to be a drawback. There's always a but. Active testing brings its own raft of problems. So we put a probe either in front of the origin server, testing all of the streams and the profiles in the origin server, or we can test outside in the CDN. So we can test at various places using probes and active testing. So active testing works by behaving as though the probe were actually a customer out there looking at an OTT stream. We request the manifest file for the stream, and then we request the manifest files for all of the profiles. And then we go out and fetch. We request from the origin server or the CDN. We request the individual trunks. Now this is where it differs, of course, from you or I sitting at home watching Netflix. I'm only ever going to watch Netflix one at a time, although there may be someone else somewhere else in the house looking at a different stream. But generally speaking, I'm going to be looking at one single stream. And crucially, I'm only going to be looking at one profile. Now the probe endeavours to look at multiple streams. Remember, the VB330 10 gig probe can monitor up to 500 different streams, and each of those streams may have 5, 6, 7 profiles. So the probe will endeavour to get every chunk of every profile of every stream. And that is a big ask. There's a lot of traffic that's going to be generated. But the beauty of this type of approach is it acts a bit like a customer, so it's going to see the similar sort of problems that customers are seeing. If chunks are missing, if profiles are misaligned, then these can all be determined using active testing, and these will really, if there are problems, these will lead to real world problems with customers. So where do we actually want to test? Well, as I said earlier, the best place to start checking is at the origin server, because this is where it all begins. We would check at the origin server to make sure that all the chunks of all the profiles are in place and they're all compliant. And of course, we can check in the CDN. So to recap on some of the benefits and disadvantages of passive and active testing, you can see them listed there. Passive is definitely a simpler process, and it doesn't generate extra traffic because it's only testing the traffic that is currently at the switch. But active testing is a more complex process, but it does do multiple tests on the content, and it provides real-world metrics. So, without further ado, let's go straight on to looking at how the probes work in a real-world environment. So now let's look at OTT monitoring in practice, shall we? Now I'm looking at a VB330 in our demo system, and I want to go straight to the About tab and look at the licenses. Now if we look at the OTT engine option, you can see that we have all 50 of the possible 50 OTT engines licensed. Now if you've got a 1 gig probe, a 120 or a 220, or indeed a Nomad, then the maximum number of engines is 5. Remember that every engine can monitor up to 10 OTT streams. So that gives the VB330 the possibility to measure and monitor up to 500 OTT streams, and the VB120, 220 Nomad configuration up to 50. So that said, let's go straight to the OTT tab. Now, as you can see on this particular probe, we're looking at 12 streams. Right down at the bottom, we've got 2 that are in continuous error. We'll have a look at those in a bit more detail later. I just want to roughly go over this, this screen, give you some idea of what's being shown. The current status bulb is green for all but 2 of the streams. We have a thumbnail. We also have the channel name or the stream name. We have a little progress indicator that just happens to show which stream is being tested. Now, the interesting part is the alarm history, and you can see that we have a graph showing some errors here. In fact, we've got an error here, and we can see if we mouse over. So this is 120 minutes. So this is probably about 30 minutes, 20 minutes ago. We can see we had an HTTP 4XX error, probably a 404 file not found. And earlier, about half an hour ago, we had another error. If we go down to the bottom, we're getting 4XX client errors. And if we go to the bottom, we've got failed to pass manifest file. So we've got an invalid format. You can see that there are a number of profiles. NRK Live has got 5 profiles, and yet Al Jazeera below it has only 2 profiles. And you can see the current state of the individual profiles. So this is a nice little indication of any profiles that are in error at this particular moment. And if we go down to the browser, that's an internal stream generated in our lab, by the way. It's a smooth stream format, and we're looking with 3 profiles, but only one of them is actually in error. The other 2 are okay. So profile 0 and 1 are okay, but profile 2 is actually the stream in error, the profile in error rather. Are they encrypted? Well, these are all currently not encrypted, but were they encrypted, you would have a yes in that column. And then the profile information. So we've got HDS, HLS, smooth streaming. We've even got an RTMP stream there. And which engine is doing the testing? Remember, each engine can do 10 streams. So Al Jazeera Balkans and Al Jazeera English, they share the same engine, number 5. Now I'll come on to latency engines in a moment. So latency is a feature that we introduced about a year ago now. So I'll deal with that in a bit more detail later. We can change the graph to 24 hours. So if we click on the 24 hours, we now have 24 hours of alarm graphing here and 4 days. So that 4 days brings OTT up into the standard 4-day format of IP multicasting and RF monitoring. Now if we look at the bottom channel, new channel 10, it's almost certainly a test channel, by the way, from our lab. You can see that it hasn't always been in error. So about 2 days ago, we started to get errors. We started to get things with manifest file size limits. And then we had some download time. We'll look at all of these errors in a bit more detail in a moment. But basically, it then failed completely. So we've failed to pass the manifest file invalid formats. Now, you'll remember from the theory section of this OTT session that the manifest files are the text files, effectively text files, that tell the application, and indeed the probe of course, so they tell the application information about this particular stream, how many profiles the stream has, what are the bit rates and resolutions of the streams, and where to go and get those profiles. So the manifest files contain the information about the stream, where to go and get the stream, where to get them, where to get the profile manifests, and then the stream manifest contains the information about the bit rates of the individual profiles and where to go and get the profiles. And the profile manifest files give the application the information as to where to get the chunks and which chunks are coming next, effectively. So let's look at one of these. So we'll look at NRK Live, which is an HDS stream. In fact, actually, no, I'm not going to check the HDS stream because I want to show you the HLS manifest files because they're a bit more easy to understand. So if I click on the information button for the HLS stream, in fact, we'll pick the English one because it's got 4 profiles. So the profile details come up and we can see individual entries for the profile. So we've got a 915 kilobits, so quite a low bit rate profile, all the way down to 64 kilobits. So this would be typical of a low bit rate stream. But you can see that we've had errors on some of these, and because the individual profiles now are graphed, and it is only the 4 days. In fact, let me just check something. If I click 24 hours here and then go and have a look now. So we're now looking at 24 hours. So yes, whatever this is quite new to me. So when we pick 4 days or 24 hours or 2 hours, then that is reflected in the detailed graphs that we're showing now. So looking across the line here, we've got the profile of 915 kilobits per second. It's live, so in other words, it's a live stream, not a VOD asset, not a movie or a catch-up TV program. And it's telling me that the manifest file is telling the probe that the bit rate of this particular profile is 915 kilobits per second, which is pretty much as we'd expect. But then we have to go and we measure the bit rate of all of these profiles. So if we look at 398, we're actually measuring it at 395. Now if you look at the 915, just now it's gone to 800 kilobits per second. So these streams, these profiles rather, they're variable bit rates, and it's important to remember that the bit rates do go up and down depending on all of the usual compression parameters, the amount of movement, detail, and so on and so forth. So the bit rate, the actual bit rate, does change. But it's important, it's very important. Remember from our theory that the application chooses the bit rate, the profile bit rate that is applicable for the network conditions locally at that time. So the application needs to know that it can trust the profile bit rate of 915 kilobits per second. And it says, yes, I can get 915 kilobits per second, but I can't get much more. So we have to watch the actual bit rate and monitor it and then generate alarms if the actual bit rate deviates by too much. And now when we look at thresholds, you can set those. So the Bits per second. So this chunk has downloaded at, in fact, it's just changed. So the chunk is downloaded at 43 megabits. The chunk length is 8 seconds. The download time 167 milliseconds, and the time to the first byte of the file was 56. Well, and then it's changed. So this is very dynamic. This is a very dynamic situation. All of the chunks are different. Well, they have the potential to be different. So we do need to keep track on all of the chunks. So this is one of the reasons why active testing is quite important. We need to keep track of how much these bit rates change. The download size of the file, well, again, that's changing as we look. Currently 861 kilobits. So that's the size of this chunk. Is it encrypted? No. And the HTTP header, well, we'll look at that in a bit more detail when we look at the manifest files. So if we click on the manifest file tab, you can see that we can get the stream manifest, so we can actually download the stream manifest. And if we download that, so this tells me the individual profiles, as you can see, and it indicates the bandwidth. And we seem to have 2 entries for each of the profile bit rates. I'm not entirely sure why it shows 2, but you can see that there are 4 indicated, from the 255 down to the 64 kilobits. And then when we look at the individual profile manifests, we can actually see that this is the file that enables the application to keep track of the chunks. And you can see that these chunk names, in fact, the end of the URL is a number, and that's the chunk number. 847 at the top, 848, 849, and this will continue because this is a live stream and it has no practical ending. So this manifest file needs to be kept up to date. It needs to change. And it's one of the reasons why we check manifest files. So you can see we've got 11 chunks indicated on this. So that's 11 times 8 seconds, 88 seconds. So if this file doesn't update, then the application will very quickly run out of chunks. And by the same token, the management of this file needs to be kept in check. It's no good just adding numbers, adding the next URL name to the bottom, because this manifest file would grow larger and larger and larger. And this does happen. And that's one of the reasons we check the manifest file size. Then we have the alarms. And as you can see, the alarms are split into 3 categories on this particular device: transport alarms, HTTP alarms, and XML alarms. There are additional alarms, and they're QoE alarms, but they're applicable only to the VB288. We will be looking at this in more detail when we look at QoE and QoS. Then we've got HTTP alarms, so we've got no body, 3, 4, and 5XX, and you can see we've had some HTTP errors, 14 errors, and we've had a 5XX error, one of those, but no current errors. And then we've had XML alarms, and these are about things like the bitrate, indicated bitrate, actual bitrate, whether the XML is static, hasn't moved, and you can see we've had 6 of those in the past, and chunk missing, and various other XML alarms there. So to look at the thumbnails, I'm going to click on a different stream that I know has thumbnails. So we have a video thumbnail, and we can choose which particular profile that we actually decode, or we can do an auto select, and that will be generally the first one. And there's some information about the video size, the video bit rate. We've got some audio information as well that we can dive into. Now, alignment, we talked about alignment in the theory. So alignment allows us to check that the video chunks are aligned across the profiles. So we look at the sequence number and we make sure that the sequence number, where the sequence numbers are the same, the picture is also the same. So you can see it's just changed. We have a 76, 76, 76, and the thumbnails are all the same. So there's a bit of picture analysis done to make sure the thumbnails are the same. And if they're different, you will see very, very briefly during the transition period, some of them went yellow, and that indicated a mismatch. but then that settled down quite quickly. But if that mismatch remained, then that would be a profile alignment error. So we're going to close that. As I said, we're going to come on to latency in a moment. So channels is where we actually add a new OTT channel. And we won't add a new one, but we will actually look at one of them that's currently in. Now, if you notice, we have a name, we have the URL, and the URL will be either something in the origin server or in the CDN. And by now I hope that you understand what the origin server and the CDN actually are. We have some thresholds, as in the case of all Bridgetech monitoring, we use thresholds. The engine number, remember this probe has got 50 engines licensed, up to 10 streams per engine. And then we have a mode here, normal and enabled. And as you can see, if I click on that, we've only got 11 streams enabled. So let's just edit one of these. I'm going to edit one of the ones that are not enabled, just so that it shows you how it works. So first we need to enable, and then we select the engine. So this is all very similar to the way that multicasts are tested. We give it a name. Again, this is a user added name, and then we put the URL in. Now, if we put a player URL, what I'm going to do is I'm just going to copy that for a second and press. So I'm adding the manifest URL into the player URL, and I'll explain what that does in a moment. You can see that if we're looking at smooth streaming, then this gives us the ability to specify which chunk, because you can actually specify different chunks to download. VCAS, if we're doing some VCAS encryption, then this would give us the key server. We would put the key server in here. This would enable us to download the keys to decrypt and decode a VCAS encrypted stream. Availability mode is quite interesting. Now, we've talked about the way that active testing works. Active testing generates quite a lot of traffic because it downloads every chunk, or it attempts to download every chunk of every profile of every stream. And that generates quite a lot of traffic. Availability mode allows the probe to go to the origin server and ask the origin server, is this chunk available? And the origin server will reply yes or no, but it won't download the actual media. So that cuts down greatly on the amount of traffic generated at the origin server and in the network. But of course, the downside of it is that it doesn't allow you to do any checks on the media itself. RTMP, that's legacy. I'm not going to talk about RTMP. There's not much of it around, but we can get into there. We can get into RTMP and do some validation checks. We can't do any decoding or anything like that. Do we create a thumbnail? Yes or no? And do we do alignment checking? Yes or no? And now we have the settings. Consider this situation. Consider an engine that is assigned an HLS stream with a 10-second chunk length, and we set the round time to 2 seconds. Then what will happen is the probe will download a chunk, and then 2 seconds later it will try and download another chunk. But the current chunk is still only 8 seconds into the playout. So it would download the same chunk, and in fact it will try to download the same chunk up to 5 times, 2 seconds into 10. So that's a problem. We don't want to generate extra traffic. There's no need to download the same chunk more than once. In fact, in some scenarios, it's not desirable to download every single chunk. And this page gives you the ability to change the round time. So as you can see, for individual engines all the way up to 50, there's a latency engine set at the bottom. I'll explain that in a moment. But looking at engine number 1, the round time is set to 15 seconds. So this means that the probe will download a chunk and do all of the analysis on the chunk, and then it sets a timer. Well, it sets a timer right at the beginning of the process, and that timer then counts down, and after 15 seconds it will then go and download the next chunk. So you can see that with a 10-second chunk length and a 15-second round time, in fact, on the second chunk, it won't download the second chunk, it will download the third chunk. So it will download chunk 1, miss out chunk 2, and download chunk 3. Now, for most purposes, this is fine. You don't necessarily need to download every single chunk. So if you can halve the number of chunks that you download, which this method would do, then you halve the amount of traffic and you halve the amount of load on the origin server, and that's a good thing. So setting this particular parameter up is quite important. It's important to balance the load on the origin server as well as the load on the network, or the traffic generated on the network, the number of chunks that you need to measure. So that we reset the connection after X number of minutes. You can see my little tooltip has come up telling me that I reset the connection after this time. So that means that we haven't been able to contact an HTTP server, so the connection gets reset. We've set up 5 latency engines. Again, I haven't talked about latency engines, but I will come back and talk about those in a moment. We've set aside 5 engines for testing latency, which gives us 5 from 50 equals 45. So then we have 45 engines available for normal testing. And as you can see down here, engine 45 is the last normal engine available. Now we go to thresholds, and again with Bridgetech probes we have multiple thresholds, so users can use the default thresholds and create new thresholds. So let's have a look at one of these thresholds. We'll look at the default threshold. In fact, we give it a name, but we can't rename the default thresholds, as is the case in all thresholds. So the download speed error. So what we're saying here is if a download chunk is 10 seconds, so it's a 10-second chunk of video, and the time taken to download it is 100% of 10 seconds, in other words 10 seconds, then generate an error, a download speed error, because it's taken 10 seconds to download a 10-second chunk. So that's not going to work. That is almost certainly going to fall over, because if it's taking 10 seconds to download, then I'm going to run out of video. I'm going to run out of video quite quickly. And the download speed warning is set to 80%. So in other words, if it's taking me 8 seconds, because 80% of 10 seconds is 8 seconds, if it's taking me 8 seconds to download a 10-second chunk, I'm getting towards the limit. Remember, I'm downloading the next chunk while I'm playing out the current chunk. I've got to get my 10-second chunk in less than 10 seconds. So we can set the warning threshold at 80%, which is 8 seconds. Now these can be changed to anything you like. So what we're looking at here is the actual bitrate minimum. As you can see, it's set to -1, and -1 is the figure you put in to disable an alarm. So the alarms, the actual bitrate alarms on this particular threshold are disabled. But we could put something like 50% in for minimum. So let's take a bitrate of 1 megabit. So we've got a video bitrate of 1 megabit, and we are saying that if the stream manifest says that any of the profiles drop below 50% of the indicated bitrate. So in our particular example, we've chosen a bitrate of 1 megabit per second. So if the minimum bitrate drops below 500 kilobits, which is 50%, then that will generate a minimum bitrate alarm. And by the same token, if we put 150% in there, if our maximum bitrate goes above 1.5 megabits per second, in other words 150% of 1 megabit, then that will generate a bitrate alarm, a maximum bitrate alarm. The sequence age, so in other words, if I'm downloading my manifest files and I check them, and if they have remained unchanged, in other words if there's been no change in 60 seconds, then that will generate a manifest sequence age alarm. That makes sure that the manifest files are updating. The manifest file size, as you can see, this is in bytes. So we've got 500 kilobytes. If you remember, I said that the manifest files can grow. And this is done because the the mechanism that's generating the manifest files adds the new profile URLs to the bottom of the file, but then fails to remove the top part of the file, which is now in the past in time terms. So it's really important to keep track of the manifest file size. And then the minimum number of profiles. If you need to keep an eye on the number of profiles, say you have a stream, an OTT stream that has 6 profiles, then you can alarm if that number drops below 6. Okay, let's go back to latency. Now, latency is quite important in some circumstances, and some people need to know about latency. So what is latency? Well, if I am measuring at my origin server, then I'm doing exactly that. I'm measuring right at the beginning of the process effectively. I'm not measuring in the CDN. So one of the metrics about a CDN, particularly for live streams, is how quickly they are propagated through the CDN, because the speed at which these chunks go through the CDN, and remember there may be multiple servers, it almost certainly will be multiple servers, and these chunks have to get to these different servers before they get to the edge of the network and then out to a player application in someone's home or on their tablet or phone. So if I'm watching an OTT stream, it's not unusual to have that OTT stream delayed by many seconds. Even a minute is not unusual. And my OTT stream is a minute behind the live TV. And in some circumstances, it's very useful to be able to measure how fast my chunks are moving through the CDN. And remember, I probably don't own the CDN, so I don't have much control over it. So it's quite important for me to be able to track these chunks and see how long. So latency is one of those features. So we can allow latency, and we can then measure a stream, a single stream. So we're looking at one stream, Al Jazeera. So we've got one channel, and we are measuring that single channel at multiple points. Now it's a bit more difficult for us to do this in the demo system because we have a sort of a setup, and we're looking at public URLs, so it's not particularly easy. We can't measure these actually at the origin server. We're measuring in the public internet on CDNs. But the principle is quite simple. I can assign 2 engines to Al Jazeera, one of which monitors the origin server, and the second engine monitors Al Jazeera somewhere in the CDN. And then I will generate a graph. So I can change this window, I can change the average window if I like, and I can see the minimum maximum. So basically I'm checking how fast my chunks are going into the CDN and being propagated through the CDN. So the latency could be quite important, and this gives you an ability to track that. You could assign 3 engines to Al Jazeera and check it at the origin server, one part of the CDN, and another more distant part of the CDN. That would be entirely possible too. So we've gone over most of the OTT setup for the probe. You now know how to add a new channel. You know how to set up thresholds, and most importantly of all, you know what the measurements are showing you from the individual profile, download bits per second, download time, chunk length, chunk size, how to look at the manifest files, the alarms in the individual probe for the individual streams, and then to look at thumbnails if we want to, and alignment. You can see we've got an error there. There's a profile alignment error, which was quite nice. So that is the last of the OTT session. Please feel free to take the quiz now. And if you have any questions, of course, remember that these sessions are not particularly closed. I'm more than happy to take questions on any of these, or clarification is needed. I am more than happy to generate a clarification video at the end of the sessions in order to clarify points that weren't particularly well explained, for example. So do keep in touch, let me know what you think, and look forward to seeing you next week.